By the end of this video, you should be able to calculate the area of a polygon using the precise formula that I am about to show you. So, in order to calculate the area of a polygon, we do have a formula for regular polygons. And that formula is, please write this down, area equals perimeter times apothem divided by 2. And I'm going to go ahead and define what each of these pieces means. Except the one part you do know is that P is for perimeter. And the other stuff is new vocabulary. So the first thing, you're calculating the area of a regular polygon. And a regular polygon is a polygon which is just a closed shape with all sides being congruent. So it's a polygon where all sides are congruent. Okay? Which would also make all angles congruent. Now the apothem is a line segment that goes from the center of the polygon to the midpoint of a side, which I'll draw in a picture in a second. Okay. So this is the formula. A stands for apothem, and the big A over here means area of a regular polygon. Okay, here's an easy example. You're given this polygon. It's got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. And we want to find the area. So area is perimeter times apothem divided by 2. So in order to calculate the area, I need to know the perimeter and I need to know the apothem. So I would have to tell you that this is a regular polygon, which means all sides are congruent. So they would all be 12. Okay, and I could go on forever to figure that out. But that would take too long, so I'm not going to. Now, in order to calculate the perimeter, I can add up 12 9 times, or I have 12 nines, so it's just 12 times 9, which is 108. Okay, so I need perimeter times apothem, then divide it by 2. The apothem is a line segment from the center of the shape to the midpoint of the opposite side, or A side. So here's the center of the shape. Here's the middle of this side here, which makes this the apothem. Okay, so the length of the apothem is 16.5, so I'll just plug that into my formula and go ahead and calculate that. So times 16.5 divided by 2 gives me 891. And since it's area, I need units, but I wasn't told units, so I'll just say unit squared. Units squared. Okay, so that's formula. That's how you would use it in this kind of a problem. Now, the harder examples would be if you're not given all the information you have. So you know this is a regular hexagon and the side length is 8. So all of these sides are 8. Okay, now in order to calculate the area of a regular hexagon with a side length of 8, I need to know the perimeter, which I could figure out, but I also need to know the apothem, and then I would need to divide it by 2. So the perimeter, this is a hexagon, so there's 6 sides. So 8 times 6 is 48. So I'll do 48 times A divided by 2. Now, the apothem of this is going to start at the center and connect to the midpoint of the opposite side. And I don't know this length, which makes this problem a little bit harder. What I do know, though, is that I can cut up any regular hexagon into a bunch of triangles. So let's take a look at this triangle. And this is going to connect us back to Unit 5, what we learned first semester. Okay, so I got to figure out what this length is. So I need to know what kind of triangle these are to figure out what the length is. Now, if I draw in the apothem is also the altitude of this triangle. So the apothem will always be an altitude of a triangle. That makes this a right triangle. What kind of right triangle, though? Well, if this is a regular hexagon, we know that all the angles in a hexagon need to add to 360, which there are 6 angles. So if I do 360 divided by 6, that means each angle here needs to be 60 degrees. So what kind of triangle is this? Well, if I know that this is a regular hexagon, I also know that all of these side lengths have to be the same. Now, if these are the same, that makes this an isosceles triangle. And if this is an isosceles triangle, then these angles have to be the same. But I also know that one of these angles is 60. So if these angles are the same, and this is 60, well, 180 degrees in a whole triangle. I've already used 60. That means there's 120 left for these two base angles. Divide that by 2, each one of those would also have to be 60. So this is an equilateral triangle, and I can use that fact to find the apothem. Because this is a right triangle, I can use special right triangle relationships that you used in the last chapter. So here's just a zoomed in version of this triangle here. This is 60, this is 90, this has to be half then and be 30. So 60 plus 30 plus 90 equals 180. I know that this, the whole side length here is 8. So what's the length of this side? It would have to be 4. The hypotenuse is always 2 times the shortest side, so opposite the 30 is the shortest side, so this would have to be 8. And across from the 60 is always your shortest side times the square root of 3, so it would be 4 root 3. So that means the apothem here is 4 root 3, using special right triangles. So our final calculation would be 48 times the apothem, which is 4 root 3, over 2, which you will then calculate. So let's see, the square root of 3 is 1.7 something. Multiply that by 4, multiply that by 48, and divide that by 2. You'll get the area of the whole shape is 166.2, and I'll round up to 8.28. Again, I don't know units, so I'll just write units squared. And that's the formula for the area of a polygon. If you're curious about where this formula comes from and how to derive it, the good news is that's what we're going to talk about in class. So be ready for that. And if you have any questions, please raise your hand and ask.